Hello everybody, this is Michał Szrowiak from Poznań University of Technology. In this lecture we'll be talking about some principal and paramount security mechanism implemented by common and typical computing systems being of ubiquitous use today, from the traditional desktop computing to modern cloud and IoT computing. But before we get to the meat of things, we need to talk about some initial assumptions. In order for you to get this lecture nice and smooth, you must have some initial background knowledge already. I obviously can't start our lecture from the very beginning, Big Bang, formation of stars, constitution of galaxies, beginning of life, all this. And since I want to get to some interesting things within our limited time span, I have to suppose you are familiar with some topics already. For instance, you should know what does this acronym stand for. And here it doesn't mean the well-known American agency, but the three basic properties of data security, which are confidentiality, integrity, and availability. Then I suppose you already know what the terms authentication and authorization mean. Finally, I'll expect you to be familiar with fundamental theory of operating systems. What are processes? How new processes are created? What file system is? What are system functions, etc. And you are truly capable of using Linux and Windows OS with ease. Now, having cleared that matter, we are good to go. So let's go on. Our leitmotif here is security of big data. It's the first buzzword, right? Big data. Frankly, big data is just data, only really big. The internet produces a tremendous tsunami of zettabytes, not peta, not exa. It's thousands of zettabytes of information which are collected and processed, something that in practice requires involvement of first, cloud computing for analytics, and second, and that's yet another common buzzword, the smart objects, smart devices, collecting those unspeakable amounts of analytic data, what we all know as IoT or Internet of Things, and edge computing or fog computing, right? As you probably know, the number of mobile devices has overrun the number of human beings many years ago. And according to Cisco systems, mobile data traffic has grown tenfold globally for the last 5 years, reaching more than 20 exabytes per month worldwide. Look at the whole number of various sensors your own mobile phone is equipped with. They all relentlessly collect data. As a matter of fact, I can be proud considering myself one of the very first users of a mobile computing device, which I have been already using 30 years ago during my studies, years before the advent of big mobile market players. But what is more interesting, it seems that world-famed engineer and inventor Nikola Tesla predicted the IoT phenomenon even earlier, about 100 years ago. He had already foreseen that if we could gather all the information in the world, we would indeed get a very thorough insights on how our business processes are running. And this is exactly the vision of the Internet of Things and big data. So, what is IoT exactly? Nobody knows for sure. There is some attempt to standardize and define that topic but the IEEE document is already 80 pages long and still counting. But however you would try to define the topic, one particular thing always strikes out. It's the heterogeneity. Pretty unusual for IT people working with desktop computers and used to play with only two main operating systems, Windows and Linux. And for application protocols, mostly HTTP, almost the one and only, besides some compulsory utility protocols like DNS or LDAP, for instance. So the landscape is pretty stable. In the IoT world, it's not the case anymore. We got a plethora of different technologies. High-level messaging protocols, such as MQTT, message queue telemetry transport. Advanced message queuing protocol, constrained application protocol, data distribution protocol, extensible messaging and presence protocol. They play the role of application layer protocols that run on top of lower layer communication protocols and provide the ability of data exchange. It's a huge topic with a lot of literature, a lot of conferences each year. Some particularly fascinating. I admit, I failed to attend this one, pity. There might have been some interesting hands-on workshops. Never mind. Well, let's go back to the business at hand and have a look at the picture describing typical communication architecture of an IoT application protocol. MQTT, for that matter. What can you see right in the center of that architecture? Yes, this is cloud. You know, nowadays a profound shift is taking place. Instead of managing their own data centers, many companies are moving to the cloud, taking advantage of services such as Amazon Web Services, Microsoft Azure, Google Cloud Platform. Cloud is a computing architecture put forward by Google around 2008. So, besides those initial assumptions, I will also assume that you are familiar with those basic cloud architecture models that you can see on this slide, which are infrastructure as a service, platform as a service, and software as a service. They differ in the scope of responsibility shared between the cloud provider and the customer. The dark blue depicts what the customers must provide on their own. The light blue is what they got from the cloud provider. Aside those three, let me call them fundamental cloud models, there are also many other asterisk as a service concepts, such as the extensively used by mobile application, so-called backend as a service, offered by all major players on today's cloud market, Facebook, Parse, CloudMine, StackMob, etc. It offers easy database access, automated push notifications, etc. And finally, the last example, a relatively new paradigm, already very successfully applied to web applications and big data, is function as a service. Here, the only thing a user provides is the bare code, fine-grained functions, not the infrastructure, not the operating system, not the application platform, not the runtime, only the code. But we need to be aware that there's an essential misconception that users can take the software which runs on the conventional network protected by a company firewall and just run their applications on the cloud without much further security consideration, because the cloud is commonly considered safe, at least safer than a typical local network protection. The truth is, users miss the point that the applications are running on someone's hardware over which they have limited or no control. The cloud has also another important impact on security. Taking over plentiful in-cloud virtual machines means that attackers have remarkable striking force at their disposal for launching denial of service attacks or breaking passwords, among others. Actually, cloud providers usually clearly state what security measures they claim to be responsible for and what is left to the user's concern. But users still seem to be invariably unaware of those. And by the way, it is worth noting that cloud providers may promise high level of security and privacy, and they can deliver it. The same rigorous standards often do not apply to their subcontractors. So there's a newly born need for security techniques encompassing cloud access from both enterprise and remote mobile users. One example of those is the Zero Trust Network Access paradigm. And Secure Access Services Edge architecture, formerly known as Secure Internet Gateway, similar to Zero Trust Edge from Forrester and some other comparable models. The Zero Trust Network concept is built upon the fundamental assertion that the network is always assumed to be hostile, with both external and internal threats prevailing on the network at all times. Therefore, we must undertake the same appropriate precautions when accessing the resources, regardless of whether the access originates from a remote worker or from our internal corporate network. Well, it means that access control is not centralized anymore inside the corporate network behind a corporate firewall, but is distributed over the wide area network with a heavy use of available software-defined networking features. As with progresses Cisco Umbrella for the clients, all the clients of Cisco AnyConnect platform. According to Gartner's definition, Secure Access Service Edge is a unified cloud and on-premises architecture that assembles multiple network security functions like secure web gateway or firewall as a service with software-defined wide area network to provide secure cloud access to the users and their devices. Software-defined wide area network is a solution to manage a company's multiple wide area networks, which could be internet, LTE, fiber, etc. So SD-WAN uses SDN appropriate technology to control the entire environment. Its main goal is basically to direct the flow of packets towards appropriate networks in order to optimize costs. So, if you find this idea of zero trust network access interesting, you should first explore the whole topic of software-defined network and software-defined wide area network as part of your cybersecurity studies, because that's definitely something to become very important in the incoming days. Okay, so that was some background. Whether we speak about big data or not, one thing remains constantly true. Protections will always be imperfect, and we will still have some vulnerable components exposed and subjected to potential attacks. This is particularly significant for, first, long-running applications, especially in the cloud, of unpatched virtual machines or containers or mutable containers, which are more difficult to patch than the virtual machines. And second, for the IoT devices, some of which never get patches at all.